We discussed type of data. Jennifer, can you quickly remind us what it was all about?
Um, Sorry, my place is a bit noisy. I don't know if you can hear.
We can hear you loud and clear.
Okay, so we spoke about the types of data, sorry, and there are two distinct. We have the categorical data, and then we have the numerical data.
Mhm.
And then the categorical data, they are divided into nominal and then ordinal. Why the numerical data are discrete and continuous data.
Thank you very much. And we highlighted the following steps as data analysis process, right? We said these following steps are the process of analyzing your data. You must define your problem. You must extract your data, clear your data, transform them, explore the data, predict your model, and model validation and testing, visualization of your results, and you deploy your solution. So these are basic steps. Can you see my screen?
Yes, sir, we can
Thank
see.
you. So these are basic steps you need. So you have to memorize this by heart so that it's just like someone who is
Yeah.
walking through or how to cook a certain meal. So the first step, you set your fire, you take your cutlery to it, you put your food, you understand, for maybe some minutes. So those steps in cooking, maybe jollof rice. So that's same idea, which you know them by heart. So also you know your data analytic process by heart, okay? So these are the steps. So and we all these steps are we combine all these steps, we call them the system. So we say this is the system of which data analytic process is being what is being done. All right, so we'll go to this paper, to this other text, chapter 2. So we'll quickly review this chapter 2, then we get ourselves dirty with data coding, you understand? So we just have to give ourselves some theoretical background before we go to practice. So we said data, it's all about what is how we collect our data, how we store our data, transform the data, and report it. This process is known as what? Data science process. How you get your data, how you transform them, how you store them, they are very important. So there are some things you need to know about your data. So your data is just like what? They have what we call attributes like properties, like attributes of your data. Understand now? So what are the attributes of your data? Just like you have human. So we ask what are the attributes of this person? What are the characteristics? What are the behavior of this person? Understand? So these are what we are trying to look at when we talk about data attributes. So we said we call something data sets. So this term is very important. Your data sets, okay? Data set is that what? Is that collection of your entire data. If you have names of, remember, okay, let me go there. So if you have names of people in a certain um, location, maybe some people who lives in okay, for instance, now name of student in your class in maybe in 400 level in your university. So it's a data set. If you get all the names of the boys and the girls, their first name, second name, and the middle, and their surname, that is what a data set. So it's just a complete information about a certain group of persons or group of things. So they can be structured. So it has to be well structured. Yes, your data set has to be well structured. And also your data set has to be in rows and what? Rows and columns. Okay. So that is how it is being designed. So data set is always good when they appears in a tabular form. So, and this is also refers to as what data frame. So please take note of that also, data frame, because we'll be seeing those things as we continue to proceed. Again, there's what we call data points. So data points is that what is those item in the rows. You understand? Like a row. Let me visualize something. So let's say this is a table. So this is name. So this is, let's say this is age, and this is weight. So first person, second person, third person. So these are called what's it called? These are called your attributes. Let me call this one X. So these are called your attributes. Age and what? Your weight. They are the attributes to what? To your data. This first person, this first guy, is a data point because it contains information of his age. Maybe he's 10 years old and his weight is 40 kg. Let me say 45 kg. Understand now? So this guy is what? Is a data point. Similarly, this guy, number two, is also a data point. Let's say his age is 18 and his weight, so his age is 19 and his weight is maybe 100. So these are another data points in your data set. So they are what? They are records. They are objects, or they are just like examples or instance of a single instance of what? Of the data. So this is an instance of a data. I hope it's clear. This is also an instance of a data. Okay. So attributes are what? Are those inputs, are those fixtures, are those variables or predictors. So they have single words, is a single property of your data set. Each column in your in each column, just like I've said, age and weight, these are what? Your attributes. They could be they could be what? Numerical, they could be categorical. Remember, we only look at two types of data in the last class, just like Jennifer has read for us. We look at this. There are other forms of data type. Okay, other form of data types are what? Look at this. Date time. Okay, please take note of this. Date time is a type of data set. It's not categorical and it's not numerical. Date time. So sometimes you see some data sets which appear to be on the 20th of April of maybe 2025 or 2005. You will see something like this, dot 10:45. So it's telling you that this data set was collected on this date and on this time. I will show you an example. Let me quickly go to my data, my Google Drive. Okay, let me show you how a date time instance looks like. So you need to see all of this so that let me go to my drawer. Okay, I think I have an Excel here. Yeah, let me see this. So this was a data set that was collected. Let me see if that is it. Yeah. Oh, not this. Sorry. So this was a questionnaire that was used, and yes, look at this. This was a data set that was collected in 2021. Can you see my screen?
Yes, sir, we can see.
All right. You can see this timestamp here. Can you see the timestamp? You can see now, this is not numerical data, it's not categorical data. So we classify them as what? Timestamp. So it takes the date. This was on the in May, in May 19th, 2021. Look at the time, 12:11, 12, 11 minutes past 12, 15 seconds. This person data was collected. The same day, this person data was collected, differ by 4 minutes. This person data was collected, differ by what? About 50 seconds or 20 seconds. This person data was collected, differ by a minute and some seconds. So you can see now, these are data points that were collected from individuals. You understand now? But the data, you can see this is text. You can see this is what? Date, time. So it takes date and time. Please take note of that. So that is how date time looks like in your data set. They are very difficult to handle. So as time goes on, we'll continue to play with all of this to see how we can handle date time problems. Are we together? So let's go back to our text. So that's what we call date time. So we've seen numerical data, we've seen categorical data. Categorical data are just data that are either yes or no, that are not what, that are not numbers, okay? Maybe warm, hot, warm, and mid temperature. Maybe high, low, and mid temperature. Maybe good, poor, and you understand? So all of these are categorical data. Numerical data are just numbers, okay? Data in numbers, maybe your age, your height. So data in text, you've seen an example now. Data in text, this is a data in text, like the full name of the person, data in text. Like the matric number is an example of numerical data, right? So timestamp is an example of date time data. These are other text data. So like this person, so these are the daytime data. Okay. So now you see what the time data is. So it can also be Boolean data. When we say Boolean data, it is either yes or no data. Okay. So for zeros and what? Zeros and one. They are generally known as what? Boolean data. Are we together? So now here's an example that was given to us of a data set. So this is, so if you look at the borrower's ID, so this is data from a bank. So bank, before bank can give you a loan, they will need to check what? They will need to check your credit score. So and be able to, so they will be able to predict your what? Your interest rate, that okay, because of this type of thing, this is the interest rate that will be given to this person. So people with this amount, they'll be able to calculate the interest rate for that person. So now, so look at this table two. This is a new person, a borrower, 11, number 11. It has about 625 credit score. Now, what will be the interest rate? So with data analysis, you'll be able to calculate it. So are we together? Yeah. So we have what we call what? A label. These are very important. So label class. So when we want to predict, you need what we call label class. You need what we call output prediction. Your output, your prediction, your target. You understand? Just like I used to use this example as as a good example. Y is equals to what? Mx plus c. This is a very good example. So x is your what? Is your prediction, is your target. Okay. Y is what? Your prediction. I want to, if you have from your target, you want to predict what Y will be. So this is target or your response. So what will be the response? Calculate a target or what will be the response. So when X is Y, when X is 1 and the M is maybe 2 and your C is what? Your C is maybe your C is 5. So what will be Y? Y will just be 2 times 1 plus 5, which will give us what? 7. So you'll be able to make what? Your prediction. So your prediction is what? Is 7. And your target is just what? 1. So you have a target class. If you have a prediction class, then you are good to go. So identifiers too, they are very important. identifier. They don't really provide anything about your data. So, but they help you to locate some certain instances or certain variable. For this case now, ID, borrower ID, this data is not relevant to data analysis to identify. So when you are trying to handle your data analysis, you must look for identifier, take them away from your data set. They don't add any value to it. This person number one, what does it tell you? It doesn't tell you anything. Just tell you that this person is your first item in your table. It does not add any information to your data set. Okay. So credit score is what is much more important to us rather than this ID. So in this case, you have to drop your ID when you want to analyze this data set. Okay. Any questions so far? Okay. So in absence of no question, I believe we it is clear to us. So let's quickly look at the other section, which is what? Causation and correlation. This aspect too is very important. So before you can start analyzing your data, you must try to ask some questions. What is the cause and how is this data what related to what you are trying to find? So it is important to frame the data science questions correctly in the sense that what is the cause, okay, and what is it, how does this data or how does your prediction related to what the cause is. So if the cause and if the causation and your correlation are not properly framed, is a big problem. So your data analysis will be, let me say, will be so poor that will be so poor. So to avoid that, you must look at the causation and correlation properly. So, and it helps you to know what are those factors that generally will influence your prediction. So, data preparation, like we've seen in this textbook, you can see, like we've seen in this textbook, data preparation process or data analysis process involve all of this. So, now in this other book, we are saying that for data preparation process, so we have to prepare our data to suit what? To suit data science tasks. So we have to process it to suit what we are trying to what? To identify. Because we've already seen the causation already. So you have to prepare your data towards the cause. So what is a cause? Why is it that everybody is having this big amount? So it tells you that these people are very rich guys. Their credit score is very good. So why? It means that these people they borrow money and they return the money. Nobody is running away with the bank's money. That's why their credit score is so great. So hope you know how to calculate credit score. Do you know how to calculate credit score?
No.
Um, so okay. For you to calculate credit score, is a very simple way, sha. Let me see if I still remember the formula. So, so let me get my pen. So the formula to calculate your credit score is just like um, um, how do we make it so simple that so it's about payment. So the factors that are responsible for payment score, one is the payment history, okay, is the depth of the credit, is the credit utilization. So is your balance, available balance, and your available credit, the amount you have in your account. So these are About there are about five parameters that enable us to calculate credit score very well. So the popular formula they always use is called FICO score. They want to call FICO. So FICO score is what they always use, and it range between I think 300%, 300. I think the range is between that 300 to 800. So this is when someone has this score, it has a very good credit score. So, so but don't worry, I will find the formula and send to us. So, but is like FICO. You can browse more about it. So that's what is calculating and so it's like this. The score, the score is the score
Elishina.
you have, the amount you have,
Ti canso now.
then
Se vai, vai.
minus the minus I think some certain amount.
É que chega, vai.
It's a bit long, so it takes some exponential
Se
function.
vai. A sangue foi.
So
Aí vai, eu já sei tele. A sangue coisa não sei, não.
don't worry, if I remember the formula, I will share it
Integra
with
foi
you.
muito, já
It's
foi
very
muito, viu,
long
logo já
to
foi.
calculate
Viu,
the
se já
formula.
foi ser.
So, but
Isso aí, mas vai ter
if
que ter
someone
de
has
se
a
ver.
credit score between
So
300
aí a
and
questão é fiscal,
if
bem,
someone
mais
has
bem,
value
bem.
between 300 and
Sangue já
800, is worthy to get the represent. If you look at these guys' table now, their value is between what
Ok, close.
between
Política
500
aí,
and
é
800.
close.
So they have good credit score, meaning that
Vamos
these
ver
guys
agora.
are they are when they borrow money, they what they returns their money. So that's why you see their interest rate is increasing. So now, so that is the cost. So you've seen the cost of it. That okay, when you're preparing your data, you know that this data set you have, these people they are very what they are very good guys. When they borrow, they are always paying. So you will get the idea on what you are how you prepare your data. So data preparation is also another part where you use your statistical knowledge like your mean, your median, your mode, standard deviation, your range. These are attributes that will make you easily summarize your data so quickly. Okay, they are very important so you can able to understand your credit score properly. So when you explore your data, it's like to put them in a visual form. You can also put them in visual form to see how the mix between the interest rate and the credit scores are what are related. So you see them in visual form. You see them, you see the standard deviation and the mode. So you need to play with all of these statistical parameters or variables. So you will see your data so clearly. So you be able to look at the quality of your data. So when you know the cost of your data set and you prepare it properly and you explore it properly, so it will give you the good quality you are looking at. So we said the operation is operation, data must talk. So if you process your data properly and you explore it properly, then you have a quality data that yes, your the decisions that you've made from it they are what they are very solid. So here is a graphical representation of those data scores this table you've seen. This table here 2.1. So this is just the data representation. So you can see how it is being plotted. So now when you're trying to explore your data, you are looking for the following things. Missing values. Is there missing values? You are also looking for what? So you are looking for missing values. You're also looking for what you call outliers. Yeah. So in the process of exploring your data, so you also look for what outliers. So what does outliers mean? Let me give you a good instance. Gosh. Please give me a minute. Please give me a minute. Let me fix this internet problem. Please give me a minute. Let me fix this my network. It doesn't allow me to share my screen. I don't know. Oh, can you still see my screen? So, yeah. So we said in your data, you must try to look for the following. So in your data, you must try to look for the following. You must try to look for missing values and outliers. Okay, these are the things you need to look for when you are trying to handle your data set. Oh my God. Okay, let me see if I can spend the next 5 minutes before the meeting goes off. So you must try to look for what? Missing values and what? And you have to transform your data and also look for outliers in your data sets. Okay. So now our task, what we have to do now. Okay. Outliers. Then you also look for your feature selections, how to select your features. They are very important. And lastly, you have to do data sampling. This is very important. So it's a process of selecting subsets of what? Of your data points that represents the original data for the use of analysis or for your modeling. So data sampling are very important too. Okay, then before you talk about your modeling. This modeling, we'll look at this here. So the modeling is also very simple to do. So it's a process where you split your data into your what? Test and training and your training data. So the standard is what? 70-30. So you divide your data into what? 70 to 30%. So 70% for your training and 30% for what? Your testing. So all of these are what we're going to look at today. Look at, for instance, there are 10 data here. Okay, so you split them. So these are first about 7 data, right? There is so 7, which is like 70%, and 3 is what? Your 30%. So that's how you model your data. So then you build your model, evaluate your model, and you provide your final scores. Okay. So with this now, let's look at how we can formulate our tables. Are you there? Can you hear me? So let us see how we can get our data into, how we can input data and analyze our data. So we'll be using the Colab, okay? So here is our Colab. So here is our Colab. So let's see how we can replicate this data. So we want to look at what data entry or data frame. Can you see my screen? So we want to look at, we want to talk about what the data frame. So how do we form our data frame? So there are some libraries in Python that help us to handle what data frame. Before we start that, so let us quickly look at some of the libraries. So one of the library that help us to handle data frame is what we call your pandas dataset. So pandas library. So pandas library is one of the many Python library that enable us to handle data frame effectively. So let us look at some common features in this pandas, how we can use this to create our data sets. Okay, so now let us take for instance we have those data. So we use yes, just a minute. So pandas has its own keywords that we're going to be using. For instance, we use pd. So we import first. We import what? We import our pandas. Okay. So we import pandas as pd. Okay. Then we can create our data frame. So you run that line. So then we can now, so it's running, working, it's loading. So we can now create our data. So data is like what? Is like, so we can provide our data in form of dictionary. Okay. Let's provide our data in form of dictionary. Remember it takes what? Let's say it takes name, and what? Name. And let's say it has a list of a name. So the list of the names are what? John, Alice, might small letter, Alice, and let's say um, what other names is there? Let's say Paul. Okay, these are names of persons. So so put a comma here. Please don't forget. So you put your comma here. Don't forget. Okay, put a comma there. Then let's say the age of the person, the age. We have 3 persons there. So we are using a dictionary method to enter our data into our data frame. Okay. So let's say the age of the person. So we provide it as a list of what? The age is what? 25. They are integers, right? 30, and let's say 15 or 14. All right, so we have three names here, and we have three names for the age. Put your comma here, don't forget. Then maybe what do you want to put? Let's say city. City is what? City is a string. So city, where these guys live. So city is where these guys live. And what's the name of the city? So provide them as a list of city. Let's say one person is living in Sokoto. So it's a string of lists. Sokoto. Then the other person is living in Lagos. And the other person is living in Kaduna. All right. So these are the places. These are the city. So now let's form. So let's say, does these people earn money? Let's say they are workers and their salary. So maybe they have salary that are being earned. Salary. All right. So salary comes in as a pair and a list. So for Alice is being earned 1,000 naira. For John, he's 30 years old. Let's say his salary is 2,000 naira. And for Paul, he's just 14 years old. They used to give him feeding money. So let's say he doesn't have salary. All right. So then, yeah, run this. Yeah, you can say it's working. So the next thing now is to call your library. Okay. So you say your data frame. So you have to form your data frame now. Data frame. So is equal to what? You've named your pandas with an alias name called PD. So you can use anything. There can be PD, it can be PS, it can be AK, it can be one, it can be anything. So just an AKA is an alias name for your data set. Instead of you writing pandas, you just write it in an abbreviation PD. So you say PD dot what? Dot uh, data frame. You please take note of this. This data frame is in capital letter data, and the frame F is also in capital letter. Please take note of that. Data frame. So you open a bracket, is a function or is a method. Then you enter your data into it, your data. So then let's see our data frame. So you call your data frame now. Voila. You can see you have a very beautiful table. Okay. It has names is John, Alice, and Paul. Age is what? Age is 25, 30, and 14. The city is what? Sokoto, Lagos, and Kaduna. The salary is 1,000, 2,000, 0. So this is how to form your what? Your data frame. So we can also use this idea to form this data frame that we have here for these guys. So let's form this data frame. So which has borrower's ID, credit score, and what? Interest rate for these guys. So how do we form this data sets? So using the same idea, just come here, copy this guy, okay, come into a new line, paste this guy. So what do you do here? You call this one borrower, right? Borrower, borrower. Okay, this is the borrower, and we're told that is what a is a is a what is a not a string, but it's just number 01, 02. It's an ID. So borrower ID, please put ID there. Borrower ID 01, 02, 03, 04, 05, 06, 07, 08, 09, and 10. I think that is what we have in our data set. Yes, 01, 02 up to 010. So it has 500, 600, 700. Please Look at it and tell me 500, 600, 700, 800. Okay, let's go with that. So that's credit score. So credit score. So we create a column called credit score. So started with what? 500, 600, I think that's 700, 800, 800. What again? So credit score was 500, 600, 700, 700, 800, 800. Okay. So 700 is 2, 800, 800 is 2, then 750, then what again? 750, 550, 650, and 825. So we have 750, 650, 825. So this is the credit score, and we're giving some interest rates. So the next column is what? Interest rates. So it means we don't have salary, so it's just what? Interest rate. The interest rate in percentage. So we are giving some interest rates to be what? What are the interest rates? Can we sit together? Can you hear me? All right. So our interest rates are, I think 750, 550 is missing. Okay, 550, 550, 750, 550, 650, and 825. Okay, so interest rates was 7.31. What again? 6.70. What again? 5 point what? 95. What again? 6.40. What again? 5.40. What again? 5.70. Again, 5.9. 7.00. And again, 6.50. And again, 5.70. So this is what we have. Okay, so when you run this, it said, what's the issue? Borrower's ID. Okay, so we cannot use 0.01, so I just use 1. Okay, so you cannot use decimal like that. It doesn't recognize it. I'm saying this for the first time. I thought it recognized all numbers. Okay, yeah, you can see now. So we have the same table. We have the same table as what? As was presented to us in this what? So in this text. Are we together? So we have developed the table. So now let's quickly do some little exploration. But we discovered that what? We discovered that index is there. Look at this column, it's not part of it. How do we remove this column? So how do we remove that index column to ensure that we only have 3 columns instead of 4 columns? So how do we do that? So there is a way of handle that to remove that column. So we can just say, oh, we want to remove the column. Then let's call this one index PD data frame 2 is equal to what? Is assigned to what? Data frame dot what? Reset. So there is what we call a reset function. Reset index is a function. Okay. So we use reset index function. Then we print data frame 2 now. Oh, no, this is not what I want. Mhm. Then we do drop. We have to drop it. Drop is equals to what? Is equals to true. So drop is equals to what? True. So we set the drop to true. Okay. And let's see if that will give us what we want. Hasn't given us what we want. Hmm. Okay. We want to drop our index column. So we want it to be like this column should go away. Yeah. Let me see. Data frame, print data frame to reset index dot drop. Hmm. Okay, let's continue. I will figure that out. No, I don't have an index name for it, so that's why it's a bit difficult to remove. So let's explore our data. So let's calculate the length of our data frame. Okay. So let's say how many lengths, the length of our data frame. So we can use the keyword. So now we have our data frame. Let me run that again. So df, we provide our data frame. So I want to see the first 5 rows of my data frame. The first 5 rows of my data frame. I'll do df dot what dot head to see the first 5 rows of my data frame. So I don't want to see the entire data frame. I just need the 5 rows. I use df dot what dot head to see the first 5. If I want to see the last 5, I will do data frame dot tail to see the last 5 of my data sets. So it shows us from where? From number what? From 5 to 9. So then if I want to see some range of my data sets, df, I just want to see some certain value, maybe from 2 to 8, 2 to 8. Let me see. Yeah, you can see I just want to see from number 2. I don't want to see from number 1. So you use what we call slicing. So this is called slicing. So you want to slice your data set. So I want to see from number 2 on the list to what? To number 7, to number 8. So you can see now that it's always 1 less than. So you print from 2, 3, 4, 5, 6, 7, and 8. So there are 8 numbers here, but it will always be 1 less than what? The actual value you have there. So let me repeat this again. So let's say I want to print from 5 to what? From 5 to what? To 7. So I'll be expecting to see 5, 6, 5 and 6, right? We're expected to see column 5 and column 6 alone. Good. So I'm saying column 5 and column 6 alone. Yeah. So that is slicing. So it's always one less than what you want to, because it's a zero index array. That is why. So let's say I want to slice from item number 3 to item number 9. Definitely my rows will end in where? In item number 8. Yes. So this is how you slice your table. Okay. So again, you could check the length of your data set. How many items do we have here? You want to do length of what? Of your data frame. So what will be the length of your data frame? So you know there are 10 items there. Okay. So if I do data frame dot what? Info. Okay. Data frame dot info. It tells you what your data is all about. That look at, you have what you call the column called borrower's ID, and it contains 10 items. There is no null. That means no number is missing. That's meaning of non null. No item is missing, and they are what? The data type is what? Integer. Here is a credit score, column for credit score. There are 10 items there, no null. Okay, and is what? Is integer. And there is a what? There is interest column. There are 10 items, there is no null, and it contains what? Floats. You can see float means decimal, like we have here now. You can see it has decimal in the interest column. All right. So this is, so you can actually now, you cannot find, you cannot check, is there missing number? So let's check if there are missing numbers. Okay, missing numbers. To check if there are missing number in your data set. So to check if there are missing numbers, you do df dot what? Is na dot is na dot sum. So let me do the first one. Is na. Is na, you can see it's a question, so it's going to return boolean to us. You're asking, is there no na value that are not assigned? Is there? So it's a question, so it's going to return either true or false. So you can see now that it returns that everything are false, meaning that what? There is no na values there. So now you want to check how many are they. You understand now? So you can now do df dot what? Dot sum dot is na dot what? Sum. You want to check how many, because want this first, if you have a very large data set, it will be very difficult to, like, okay, see everything false, 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 but you want to see it in a numerical perspective. Okay, so you do what? So it's telling you that, okay, in the borrower column you have 0 na there. In the credit score you have 0 na there. In the interest, so meaning that what? There is no missing value.